Hey guys, what is up? Welcome back to our Form 4 weekly lesson. This week, we are going into hydrostatic skeleton. Alright, so if you still remember last week, we learned about insects, which is an exoskeleton. Okay, how they change their shell, which is called ecdysis, and then the stable stage, not growing, we call it instar. Okay, so the baby phase is called nymph until it reaches adult. Alright, today we are talking about hydrostatic, okay, especially particularly about earthworm. Okay, 家境 tanah 蚯蚓. Okay, so earthworm, they don't have any hard shell or any hard bones inside. Everything is soft. They use pressure to liquid pressure to support themselves, okay, to support their body. All right, so let's look at the points. Okay, earthworm has hydrostatic skeleton, which means its body cavity is filled with fluid, so it's like a water balloon. All right, and then fluid exerts pressure on the muscular wall on the body and cause body to be firm. Okay, earthworm has muscles. We will talk about the two muscles later. All right, the two types of muscles. Okay, they have two muscles. Okay, is mentioned here. They are called circular muscles and longitudinal muscles. All right, what are they? Okay, so think of a balloon. Okay, imagine this is a balloon. All right, circular muscle means it's circle. Okay, so this is circular muscle. Longitudinal muscle, as the name says, longitudinal, it looks like this. Okay, it looks very funny. All right, so you might say, how do they work? Okay, think of it this way. This is circular muscle. When circular muscle contracts, it squeezes the balloon longer. Okay, and then when longitudinal muscle contracts, it pulls the balloon thicker. So it's like a opposite thing. One, I squeeze it longer. One, I pull it shorter and thicker. Okay, so it's opposite. It's like our arm. This one pulls your arm upward. This one pulls your arm outward. So can you see? It's like opposite. Bicep and tricep is opposite. Okay, so same as the earthworm. So earthworm moves on land with the aid of kete, how do you want to pronounce this? This is like hooks, go. Okay, it's like hooks, okay, that hook to the ground. It's like their arms, because they don't have arms, so they use this small kete to pull themselves forward, pull themselves forward. All right, so this is how they work. All right, so as I said just now, they work opposite. Okay, the muscle is our main concern now. Okay, that's why I highlight them. It's very important. Okay, so the earthworm moves with the aid of contraction and relaxation of circular and longitudinal muscle, takes place antagonistically. Please highlight this word. Okay, what does it mean by antagonistic? Antagonistic means they work opposite. Okay, one contract, one relax. One relax, one contract. Okay, you get what I mean? It's like our arm. When this contracts, this relax. This one gets longer, this one gets shorter, so I can flex my arm. Okay, when this relax, this contracts, this one becomes longer, this one becomes shorter, I will pull my arm here. So can you see it's like the opposite thing? Same goes to here. You cannot be both contracting or both expanding. That would be very stupid. Okay, so antagonistic. Okay, from the anterior part to posterior. Okay, not important here. All right, so how do they work? Something I want you to change here. This is point 1. This is point 2. Okay, there's a reverse already, sorry. All right, so in order to move forward, okay, they will do step 1 first. Okay, what step 1 does? Circular muscle contracts. Now this one is very important. Circular muscle contracts, longitudinal muscle relax, and then earthworm body become thin and long. Okay, or you can say go forward. Okay, so think of it this way: the balloon squeezes, and then squeezes. This part will go forward because earthworm is trying to move forward. So it squeezes. This will move forward. Okay, and then the longitudinal muscle will relax so that it can go longer. This one contracts, this one relax, and then it will go longer. It will go forward. Okay, you get what I'm trying to say? All right, and then hydrostatic pressure transfer to posterior. Check at this segment, release grip. Actually, you don't need to know all the behind ones. Okay, you don't need to know the behind ones. So actually, the chete will grip the ground. Okay, Chete will grip the ground. Okay, when you squeeze, this thing goes forward, and then the hair here will hook to the ground. If not later, I will just bounce back. That will be very stupid. So I go forward, and then I will hook to the ground. Okay, and then number two. Now I need to, my front part go forward already. I need to pull the backward forward. Okay, I need to pull it here. So what happens here? Longitudinal muscle contract, circular muscle relax. So now, this one needs to relax, and then this one needs to shorten. I need to pull my body forward. So earthworm body become thicker and shorter. Okay, and then this is mentioned just now already lah. Okay, grip the ground. Okay, you can put it in point one. Okay, my point being is, okay, the muscles. Okay, these are the main points. Okay, so at first, circular muscle contract. This one relax, go forward, and then this one at the second part, this one relax. This one contract, pull body forward. So your earthworm will move, pop, 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 pop. It's like a water balloon. Okay, because that's the only muscles they have. Alright, so antagonistic means they work oppositely. Alright, I hope you can understand this part. Very, very important. Very, very simple to memorize as well. Only two muscles here. Alright, so more of a common sense thing if you ask me. Alright, so let's look at endoskeleton. Okay, we are not going to study into detail because endoskeleton is very complicating. Like in humans, we have 206 bones. You want to learn everything? Okay, this is what we are going to learn. Of course, you won't study everything because if you do, you might as well go study doctor already. Okay, so you are only learning about the functions. Alright, so what are the functions? Okay, terrestrial means land lah, 陆地. Okay, land. Aquatic means sea lah, water. Okay, bird means air. Okay, so three parts. Okay, and then okay, let's look at land. Terrestrial vertebrates such as animals have big, compact, strong bones. Okay, we have strong bones. Okay, our bones are very strong because we have very strong gravity. Okay, gravity is pulling us to the ground. And then we have big skeletal frame compatible to support their body size. Okay, so we have strong pectoral girdle and pelvic girdle. Okay, what does this mean? Okay, pectoral means chest. Pectoral. Pelvic means hip. Okay, yao, your butt. That is your hip. Okay, so we have very strong chest and very strong butt. All land vertebrates that has endoskeleton will do this. Elephant lah, monkeys lah, cats lah, dogs lah. Okay, any land animal that has inner bones, okay, inner bones will do this. Okay, so they are joined with legs. Okay, all of us have legs. Backbone of four-legged terrestrial animals such as camel, horse, curve upward. This is not important. Okay, curvature enables backbone to withstand gravitational force. Okay, not important. All right, so like I said just now, we have very strong gravity. That's why we need very strong bones. Okay, but for aquatic and birds, they are different. Okay, aquatic, you don't need that much of a strong bone. Why? Okay, they have smaller endoskeleton. Why? The chest, pectoral, and pelvic is weak, small and weak. Why? Because they have something called buoyancy force. Sorry, buoyancy force. Okay, means water. Okay, when you jump into water, you feel lighter. Okay, that's why they don't need big bones. If you compare a whale and an elephant, 鲸鱼跟大象, if you compare these two, elephants have very big bones, but for whales, they are they are heavier than elephant, but they don't have that much of a big bone. Why? Because they have water. They just need to swim. They don't need to stand up. But elephants, they need to stand up. That's why elephants have very big bones. Okay, let me show you here. Can you see? This is the chest bone, the shoulder of chest and shoulder, same thing lah. Okay, the chest and shoulder of elephants, and then this is the butt. Okay, the hip of elephant. And if you look at whales, can you see this is smaller? The chest is smaller, and then the hip is even smaller because they have water to support them. Okay, that's why they don't need strong bones. Okay, for birds, it's even smaller because they need to fly. Okay, they need to be very lightweight. Okay, so adapted for flying. Okay, so the sternum bone, the breastbone function for attachment of muscle. Okay, birds have very strong chest muscle because they need to flap their wings. That's why when you eat any birds like chicken, you eat their breast, chicken breast, it has no fats, it's all muscle because they use this to fly. Okay, it's not very tasty as well. It's very dry. Okay, and then bird skull is small. Okay, because easy for them to fly. They have hollow bones. Okay, hollow means 空心. Okay, empty inside. So because hollow means lighter, they can fly. Okay, it's like an aeroplane lah. Okay, your car uses steel to make. Steel, 钢. Okay, steel to make. But for aeroplane, they use aluminium. Aluminium is lighter because they need to fly. Okay, I hope this makes sense. And then hollow bones, they are light and strong. Okay, move quickly. Okay, less calcium and phosphorus. They are not that strong. All right. So I hope this makes sense. So to sum it up, okay, to make a conclusion, land is heavy, strong. Sea is not so strong because they have water. Okay, birds, flying one is even lighter because they don't need to stand or whatever, they just need to fly. All right. Okay, last part, let's look at stability. Okay, stability means kestabilan, 稳定性. Okay, how stable is the animal? Can they stand up? Okay, so we look at what is point of equilibrium. Okay, point of equilibrium means 平衡点. Okay, the point where everything is zero, where they can be stable. Okay, and then let's get straight to the point. You have two factors that affect stability. This is basically when you design a building. I think you learned this in Form 2 already. Number one, center of gravity. Okay, 中心点. Okay, 重力点. Okay, center of gravity. So what is center of gravity? Like you have a square, you draw a cross, the middle is the center of gravity. Okay, where gravity acts on it is the center of gravity. Okay, so very simple concept here. The higher it is, the less stable it is. That's why higher building is not stable, lower building is more stable. That's why when you want to fight, you don't stand straight up, you crouch like that. Why? Because you increase the stability. Like when you're playing sumo, you are lowering your center of gravity, you're more stable. You're less likely to be pushed over. Okay, makes sense? So center of gravity. Next, base area. Okay, of course, like I said just now, when you want to fight, you open your legs. Okay, you increase your base area so that you're more stable. So same goes to this concept. So the bigger the base area, the more stable. Like how giraffes, they are very tall. So when they drink water, they do two things. Number one, they increase their base area, they stand wider. Number two, they come down, they lower the center of gravity. They do two things so that they can become stable. All right, simple concept. So giraffe, okay, face difficulty in drinking water, so they increase the base area and then they lower the center of gravity. So two things they do. Okay, common sense stuff lah, common sense stuff. Okay, and then kangaroos jump and stand using two hind legs. Hind legs, okay, means behind legs. Okay, 后脚. Okay, the front and forelegs are not used for standing. Kangaroo becomes unstable. Kangaroo uses its tail strut to increase the base area. Okay, that's why if you look at sports car, they are very low because they want to increase, they want to lower the center of gravity, and then normally sports car are very wide because they want to increase the base area. Okay, which makes a lot of sense. All right, so I would say this week's chapter are quite simple. Okay, nothing much to talk about. So let's go into exercise. All right, so let's do some sort of like a revision for so far what I've learned. Okay, so write endo, hydro, and exo in these things. Okay, so leech is hydro. You know as leech is 水蛭. The one when you go into forest, it's stuck into your arm and then they will suck your blood. Please don't tear it off. You need to put salt or use fire and burn them off. Linta lah. Okay, we call it linta. Okay, duck is endo. I just write short form lah, yeah. Okay, dragonfly is exo. Alright, please write true or false. External surface of body is coated with layer of wax which is impermeable to water. Oh, this is hydro. So does hydro have a layer of wax? This is false. This is for exo. Okay, the chitin, remember? And then body fluid exerts pressure on body wall. Yes, this is true. Okay, like our earthworm. Alright, so these are invertebrates. Okay, they are all both exo. State the different support system between X and Y. They are both exo. I think there's a bit of error here. They are both exo. Support system between X and Y. I don't think there's any difference though. This is the same. This is, I think it's similarities. Okay, never mind. Let's skip this question. There's a bit of error here. Okay, this shows an earthworm. What supports the body of earthworm? Okay, hydrostatic skeleton. Okay, complete yourself. How does the support structure in earthworm helps it to move? The support structure, okay, has what we call antagonistic muscle. Okay, antagonistic muscles means they work opposite. Okay, they work oppositely. Okay, oppositely, I don't know how do you say it. Okay, or one contracts. Okay, one relax. Okay, so C, give 2 examples of animals with the same support system. Okay, you have leech. What else? Starfish. Okay, what else? Jellyfish. Okay, so many. Okay, so group them into endo, exo, and hydro. So let's do endo first. Okay, U. This is U. Okay, this is U. Endo, and then you have S, and then you have Q. Okay, exo you have P, V, and T. Hydro you have R, W, and X. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay, what type of skeleton do vertebrates have? We are vertebrates. We have endo. Okay, and then C, briefly explain how pressure of fluid in cavity assists in the movement of soft body vertebrate animals. Okay, so how the pressure of fluid, I can say exerts pressure on muscular wall. Okay, remember the muscular wall. Okay, so when circular muscle, I just write short form lah, when circular muscle contracts, okay, longitudinal muscle relax, okay, body becomes longer. Okay, so move forward. Okay, so the other way, when circular muscle relax, okay, longitudinal muscle contracts, okay, body shortens, okay, becomes shorter, okay, pull back, not pull back, pull back part of body forward. Okay, so this one, and then pull it forward. All right, I hope this makes sense. Okay, okay, there we go. Compare and contrast skeleton of both mammals. Okay, so compare and contrast means similarity and differences. So what are the similarities? Okay, they are both vertebrates. Both are vertebrates. Okay, but elephant has bigger pectoral and pelvic girdle. Okay, so whale is the largest aquatic animal, a very large and heavy body advantage to live in the water. Justify this statement. So justify means how, explain why. Okay, so you have something called water buoyancy. Okay, water buoyancy to support heavy weight. Okay, so you can say no need for a large pectoral or pelvic girdle. Okay, I don't need big bones because I have water to support me. So B, exoskeleton is hard and strong. Explain how animals with this type of support are able to grow continuously. The one we learned last week. Okay, they will replace with new exoskeleton by undergoing, okay, the breaking part is called, like this is, okay, so no growth between. Okay, or we call it insta. All right, simple. So whale stranded on the beach. Okay, based on your knowledge, can a whale return to sea on its own? No. Okay, explain your answer. Because whale, okay, has heavy body weight. Okay, bones, or you can say the pectoral and pelvic girdle are unable to support its body on land. Okay, so on land they cannot support, so no movement is possible. Okay, so because it's too heavy, there's no water buoyancy. Okay, or you can say no water buoyancy. Okay, no water to support its weight. That's why they can't swim back into the sea. They can't walk on land because now there's no water, there's full gravity, they cannot support themselves. Alright, so that will be it for this week. Okay, we have finished Endo, Exo, and Hydro. Okay, next week we will go into human. Okay, so far it's still pretty easy. Okay, next week we will go into human. Okay, I hope you learned something new this week. Okay, and I will see you again next week. Bye.